Thanks for joining. In this lesson, we will practice with use strict directive in JavaScript and we will see how it works. Before 2009, when ECMAScript 5 ES5 was introduced, JavaScript had certain features and behaviors. However, with the introduction on ES5, new features were added and some existing ones were modified. To maintain backward compatibility, developers can use the use strict directive. By including this directive at the beginning of a script or a function, the code will operate under strict mode, applying the updated features and rules introduced in ES5. Now let's see the code. Recall from previous lessons that if a variable is declared without a preceding keyword such as var, there will be no error. This type of declaration, known as silent declaration, implicitly creates a global variable. The type of the variable is implicitly assigned as var. However, with the use strict directive, the possibility is eliminated. In strict mode, we must explicitly declare the variable type using var, let, or const to avoid errors. To illustrate this, let's first run the code without use strict. As expected, it works without errors, and we receive the console log output. Now let's enable strict mode by including the use strict directive alongside the code. As you can see, we encounter a reference error. This is the first rule to remember when using the use strict directive. Next, let's see a more interesting example. Once again, we will start with the silent declaration. I will copy the previous code and add a few additional strings. At first glance, the code appears the same, except for the declaration of the variable b. In this case, the assignment b equal 10 is not preceded by the var, let, or const keyword. In strict mode, this would normally throw a reference error, as the variable b is not explicitly declared. However, we overcome this error by subsequently redeclaring b using var b. When we run this code, we observe that there are no errors. I haven't explained what the hoisting yet, but anyhow, this behavior occurs because JavaScript hoists the declaration of var b to the top of the scope. Therefore, you can imagine that the var b declaration actually happens before the line b equal to 10. Let's say it can be here. Only then var b assigns the value of 10. By ensuring the var b declaration exists, we resolve the error, and there is no reason for JavaScript to raise any complaints. As a result, the code executes without errors. Next example, in this code snippet, the used strict directive is placed at the beginning of the code, enabling strict mode for the entire scope. As a result, strict mode rules and behaviors apply not only to the outer scope but also to the inner scope of the example function. Inside the example function, the assignment b is equal to 8 attempts to assign the value 8 to the variable b. However, since b is not explicitly declared using var, let, or const, strict mode disallows the implicit creation of a global variable. Consequently, a reference error will be thrown at runtime. Although we haven't covered functions explicitly, it's important to include these simple examples. Now let's explore how we can selectively apply the use strict directive without specific scopes when necessary. As you can see in this code, we don't declare the use strict directive for the entire file. Instead, we can choose to apply it at specific scopes as needed. In this example, the function myStrictFunct is declared without the use strict mode, while the nested code inside the function is declared with use strict directive. This technique allows for flexibility in the code. The outer scope remains unrestricted, while the inner scope follows the strict rules enforced by the use strict directive. By employing this combination technique, we can ensure that specific parts of the code adhere to strict mode rules when required, while other sections, like the unrestricted function, remain unaffected by the use strict directive. This approach adds flexibility to our code, allowing us to enforce strict mode selectively and apply stricter rules only when necessary. Just a reminder, In previous lessons, I explained the comma operator in detail. Now let's examine this code snippet where the useString directive is placed at the beginning. Enabling strict mode with this directive enforces stricter rules and behaviors for the subsequent code. Within the ZZ function declaration, there are two parameters named x. However, in strict mode, duplicate parameter names are not allowed. Consequently, this code would typically throw a syntax error due to duplicate parameter names when strict mode is enabled. Let's run the code first without useString directive. The expression 1,2 utilizes the comma operator, which evaluates both expressions but returns only the value of the last expression. In this case, it evaluates 1 and 2, but only 2 is passed as an argument to the console log. However, if we enable strict mode using the useString directive, a syntax error is thrown. This demonstrates the restriction imposed by the useString directive in this example. To resolve this issue, we need to change the name of the second parameter so that both parameters are evaluated correctly. As you can see, both 1 and 2 are successfully logged to the console. Moving on the next rule, in the base 8 positional numeral system, also known as the octal system, the useString directive will throw an error when encountering numbers in the format 0, 1, 2, 3. To avoid this error, we need to provide JavaScript with octal numbers in the format that includes a prefix of 0 and the letter O. By using the format 0, O, 1, 2, 3, we can represent octal numbers without triggering an error in strict mode. It's important to keep this in mind to ensure smooth execution of code that involves octal numbers when strict mode is enabled. And also delete operator cannot be used in strict mode with variables keyword var, let or const. And we get an error. And the last rule for this lesson. Some reserved words in JavaScript cannot be used when the useString directive is implemented. For example, in the statement const implements 5, a constant variable named implements is declared and assigned the value 5. In unrestricted mode, implements is not a reserved keyword, so using it as a variable name is allowed. However, if the useString directive is enabled, JavaScript will raise an error since reserved words cannot be used as variables names. It's important to note that the rules explained in this lesson are not exhaustive. We will encounter further implementations of strict mode throughout this course, particularly when we cover lessons on objects. And as always, lesson assignments. At the conclusion of each lesson, I highly encourage you to complete the assignments, as they will greatly contribute to your progress in JavaScript. By consistently practicing, you will see faster results in your learning journey. Thanks for watching. If you have any questions or need further assistance, feel free to comment below. Don't forget to hit that like button and subscribe to our channel for more great coding content. Stay updated with the latest videos by ringing the notification bell. Happy coding!